Hello friends, welcome to this video on Stokes theorem. This video will help you to state the theorem for Stokes, what is going to be the relationship and how to apply it to a problem. We will move on to the video. Stokes theorem can be viewed as a generalized form of Green's theorem. It provides a relationship between a line integral and a surface integral. A line integral is one which we denote by single integration. A surface integral is something which we denote by double integration. So, the relationship between your C and S, the curve and the surface is brought out through Stokes theorem. So, the statement is, let S be an open, two-sided surface which is bounded by a simple closed curve C. So, we have a open two-sided surface which is going to be bounded by a simple closed curve C. F vector is a vector point function which has continuous first order partial derivatives on the surface S. Then your integral over C F vector dot dr vector is double integral over S curl F dot ds vector. Integral over C F vector dot dr vector equal double integral over S curl F dot ds vector. This curl F can be rewritten of del cross F, and this ds vector can be rewritten as n cap ds. So, on substituting the requirement, the Stokes theorem can be reused of the format integral over C F vector dot dr vector equals double integral over S del cross F dot n cap ds. So this will be the formula we will be applying it to the problems to solve or any verification of Stokes theorem. We'll move on to application to a problem. Verify Stokes theorem for F vector is xyi minus 2yzj minus zxk, where S is the open surface of a rectangular parallelepiped formed by the planes x equal to 0, x equal to 1, y equal to 0, y equal to 2 and z equal to 3 above x over y plane. We have been asked to verify Stokes theorem. The first mark will be given for the formula. So first state, by Stokes theorem, we know that integral over C F vector dot dr vector is double integral over S del cross F dot n cap ds. The second mark will be awarded for your drawing or diagram. So fix your parallelepiped. What is a rectangular parallelepiped? We know parallelogram is a two-dimensional figure. This parallelogram, when I am going to view it as a three-dimensional figure, you have a rectangular parallelepiped to be formed. So this is nothing but a same kind of structure that of a cuboid. So with a cuboid, the face has been slightly tilted. So when you are tilting it by some theta, then what you get is going to be a rectangular parallelepiped. Now we will draw our axis of reference. Let this be x-axis, this will be y-axis and the top one will be z-axis. Just like our cuboid, a rectangular parallelepiped also has 6 faces. What are they? Front, back, right, left, top, bottom. So front is given by the quantity x equal to 1. So it is going to something which is facing you. So we have x equal to 1. The one at the back is called as your ZOY plane. Okay, so this is my ZOY plane. What is my ZOY plane at the back? It is x equal to 0. Now to the right, you will have y equal to 2. To the left, you have y equal to 0. On the top, you have z equal to 3. And what is missing? The plane above XOY is missing. So XOY, what is this XOY? Z equal to 0. This part is missing. So out of the 6 face, there is going to be one face which is being cut off. When it is being cut off, what happens is this yellow portion has been removed. So you have an inside and an outside. Now this yellow portion over here, 0x, the curve over here and again back will be the curve C along which we are now going to integrate. So this is my LHS, the curve C. So LHS has a curve C. What is the RHS? RHS has surface. Now, how many surface we have? Since it is going to be an open two-sided surface, we have 5 different faces. So, of the 6, one has been cut off. So, you have 5 faces. What are they? Front, back, right, left and top. These are going to be the unit vector. Along your OX, it is I-axis. So, the front has I as your unit vector. X equal to 0 at the back as unit vector in the opposite direction. So, it has n cap as minus I. Y equal to 2 is going to be in this direction. This is my direction of J. Now, y equal to 0 is in opposite direction. So, it is minus J. The top one as unit outward draw normal as K cap. So, this is going to be K. So, we are going to fix my right hand side first and then we will move to my left hand side. What I mean by verification is you will have to show that both LHS and RHS are going to be the same. Come on, we will begin with our RHS. So, what is going to be in our RHS? I wanted del cross F vector. So, that is going to be my main component over here. So, what has been given about F vector? F vector is xyi minus 2yzj minus zxk. What do you know about del? Del is the operator I dou by dou x plus j dou by dou y plus k dou by dou z. So, this is going to be my del. When I want del cross F, so cross product is the determinant. So how to get the determinant? So I will have to write the inputs now. What is going to be my inputs? So the first input is going to be my vectors. What is my vector? I, j, k. What comes first? Del comes first. What is the I component of del? Dou by dou x. What is the j component? Dou by dou y. What is the k component? Dou by dou z. So we have filled the second line. What comes next in the cross product? F. What is the I component here? Xy. What is the j component? Minus 2yz. What is the k component? Minus zx. So now our task is to compute the 3 cross 3 determinant. Come on, we will perform the 3 cross 3 determinant. So it is I vector times, close your row and column of your I. So you will have dou by dou y of minus zx minus dou by dou z of minus 2z minus j times of, always keep in mind j takes a negative value. Okay, so hide your j row and hide your j column. So what will be left out? Dou by dou x of minus zx minus dou by dou z of your what will happen? You will have xy. Next, k times of, so hide your k row, k column. So it will be dou by dou x of minus 2yz minus dou by dou y of xy. Now we'll have to evaluate this quantity. So come on, y. Is there any y? No, this will become 0. So it is I times of, with respect to z, minus into minus plus 2y. Okay, minus j times of, what is the second component? X times of minus zx. So with respect to x, it is going to be minus z. How about y? Second component is with respect to z. No z, so this will become 0. So j is over. K times of, what is going to be the first term? X, but no x. So this will become 0. So what will happen? Second term becomes, with respect to y, I have minus x. So my del cross F vector is 2y I vector minus into minus plus z times j vector minus x times k vector. So my del cross f is over. What I have to do next? I'll have to apply this del cross f and multiply it with or take dot product with n cap ds. This has to be evaluated for how many surface? 5 surface. Why? Because we know that this bottom surface x equal to 0 has been cut open. So we don't have this sixth space. We have only 5 face for our evaluation. So come on, we will see what happens over here. Okay, so what is going to be my del cross f vector, which I have computed in my last stage. We will copy paste it. 2yi, 2yi, my plus zj plus zj and minus xk minus xk. Why we are copy pasting it here? Because over here we need del cross f dot n cap, because del cross f dot n cap has to be computed. So now I have my n cap values. I'll have to take dot product. We need to keep in mind for the dot product, I dot product I is going to be 1. J dot product j equal to 1 and k dot product k equal to 1. All other mismatch combinations like I dot j is 0, your j dot k is 0, your k dot I is 0. So whatever be the mix match, all of them are going to vanish. Only I dot I, j dot j, k dot k is going to exist. So now when I consider this I vector, I take the del cross f dot n cap. What is my n cap? I. So when I multiply this with I, what alone will exist? So I dot I is 1. So only 2y will exist. When I take the second quantity, what is your n cap? It is minus I. When I take it with minus I, what is I dot I? Again 1. So what will exist? Minus 2y will exist. When I take the dot product with j cap, what will happen? Only this j component will exist. Remaining things will vanish. So what will be the value of it? It will be z. So when I take it as minus j cap, what will exist? You will have minus z. When I take it with the dot product with k cap, what will exist? So you will have this quantity minus x to exist. So my del cross f dot n cap has been evaluated. What is the next stage? I'll have to find the value of these data at the equation. So do you have any x here for substitution? No. So the value remains 2y. Do we have any x equal to 0 for substitution? No. So the value remains as such. Y equal to 2 is the plane. Do you have any y for substitution? No. So it becomes the same z. Do we have any y equal to 0 for substitution here? No. So it remains as minus z. And last one is z equal to 3. Do we have any z in this value? No. So it remains as minus x. So we have computed the values for each of these planes. Now del cross f dot n cap is over. I will have to just fix my ds. ds. What is my ds? When it is x, the remaining two are my ds. dy, dz. When you have y, you have the remaining two x and z as your ds. When you have z, the remaining two variables y and x are my ds. So now I will have to integrate on how many surfaces? I will have to integrate on 5 different surfaces. So it is going to be S1 plus S2 plus S3 plus S4 plus S5. This is going to be my S. Now, don't evaluate them individually. What we can do best is I can club the data so that this dy dz can be evaluated together. So S1, S2 I am going to evaluate it together. Why we are doing it so? Because we can see that the values over here will become easy to evaluate when I am clubbing these two surfaces. This is going to be x face, right? So I can club this dy and dz together. What can be clubbed next? S3 and S4. So when I club this x3 and S4, your dx dz can be clubbed. So my z and minus z can be clubbed. So the last one left out will be S5 alone. So when I club, what will happen? I club double integral 2y minus 2y dy dz along my S1 and S2. So what will happen to this quantity now? This will become 0. When I club my S3 and S4, what happens? I take together dx dz as my double integral. So what is that to be clubbed here? Z minus z. Now what will happen to this quantity? This will again become equal to 0. So you have just your S5 to evaluate. See, when we began, the problem was a big one. But now, after the substitution, it has become a very easy task for us to evaluate the surface. So, the only surface that has to be evaluated is minus x dy dx. So, the double integral S5 is double integral minus x dx dy. So this is going to be my dx dy is going to be my surface that has to be evaluated. Now tell me, what are the limits of x? Where does your x vary between? Your x varies between 0 and 1. So move on. Next, what does your y vary between? Y varies between 0 to 2. Go and fix this for limit. So x varies between 0 to 1. Y varies between 0 to 2. Now let us integrate. Minus x on integration is x squared by 2 between the limits 0 to 1. And what is dy on integration? It is y between the limit 0 to 2. So this gives me minus 1 by 2 into y limit will be 2. I can do this because the two limits are going to be constant. If they are constant, you can evaluate x separately and y separately. Okay. So this 2 and 2 cancels off, leaving you with minus 1. Therefore, double integral over S, which was the addition of 5 surfaces, has only one surface for evaluation, which is my S5. And what is the answer which we get for this? Del cross F vector dot n cap ds. This value now evaluates as minus 1. So now I am done with my RHS part. Now let us move to the LHS. What is there in my LHS? Integral over C F vector dot dr vector. So I need to compute my closed curve C. So what is the closed curve C? This bottom face which has been cut open is my closed curve C. So my closed curve is going to be this parallelogram in the base. So Z equal to 0 is your X, O, Y plane which has been cut off. Okay. So when this X, O, Y plane has been cut off, X, O, Y plane has been cut off, what will happen? We have this cut open surface to be my curve C. So this is my curve C. How will you traverse your curve C? You will have to keep in mind curve C will always be traversed in the anti-clockwise direction. Okay, so direction is very important. How do you traverse your curve C? Always in the anti-clockwise direction. Now let me name this border. Let this be O, which is my origin. Let this be A. Let this be B. Let this be C. So the curve along which I am going to evaluate is going to be the curve O, A, B, C. Now what I am going to do is, instead of evaluating on a single curve OABC, I am going to split it into 4 paths. What are the first path? OA along the line integral AB plus along the line integral BC plus along the line integral CO. So the curve C is now going to split into 4 parts. So for that purpose, I need to know the equation of these lines. So how to get the equation of these lines? So we will try to identify with the diagram. What is this line over here? This is my Z, O, Y plane. So what is the equation of Z, O, Y plane? So this is my line X equal to 0. Z, O, Y plane. This is going to be my Z. This is going to be my Y. So Z, O, Y plane. What is Z, O, Y plane? X equal to 0. How many units you have moved in front? You have moved 1 unit in front. When I move 1 unit in front, what will I have? I will have this AB line. What is the name of the line AB? X equal to 1. Okay. So now about this XOZ plane. What is the equation of XOZ plane? This will be referred as Y equal to 0. How many units I move in the y direction? I move 2 units in the y direction. So this will be the line y equal to 2. So I am going to integrate along OA, which is called as y equal to 0. Next I am going to integrate along AB, which is called as x equal to 1. Next I am going to integrate along BC, which is called as y equal to 2. And next I am going to integrate along CO, which is going to be called as x equal to 0. So my integral along the curve C, f vector dot dr vector is going to be now computed for 4 parts like this. Along y equal to 0, along x equal to 1, along y equal to 2 and x equal to 0. Now what is the function over here which has to be evaluated? Come look into it. F vector dot dr vector. Now, you may think again this is going to be a little complicated. Okay, not so. Because this is also going to turn out to be an easy task. Why? You can see that where is your F vector being drawn on? Above the XOY plane. What happens in the XOY plane? The name of the XOY plane is Z equal to 0. So what happens when Z equal to 0? Now in this F, here I have a Z, so this will become 0. Here I have a Z, so this will become 0. So what will be left out of my F vector? Only this x, y times of I will be left out in my y vector. Okay, so what I am going to do? My integral over C f vector dot dr vector has now reduced to f vector equal to, what was the reduction to? X, y, I. X, y, I. So this is my f vector. What is this dr vector? Now, I know that the position vector r is xi plus yj plus z times k. So, what will be my dr vector? It is dxi plus dyj plus dzk. Now, where is my f vector dot dr vector drawn? On the xy plane. On the xy plane, what happens? My z is equal to 0. If z is equal to 0, what can you say about dz? Dz will also be 0. So this portion will go off. So you will be left out with just dxi plus dyj. But now get back to your f vector. This f vector has to be taken the dot product with this dr vector. So how to compute the dot product? I dot I, j dot j, k dot k. Only this will be equal to 1. The other mismatch combinations will be 0. So when I take my I dot I to be equal to 1, so what will happen? This dx will now take dot product with this dx. So I dot I is 1. So integral over C f vector dot dr vector will now reduce to integral over C x y dx. So this is the portion alone I am going to evaluate. And this portion is going to be evaluated for what? x, y dx has to be evaluated for along OA, along AB, along BC and along CO. What I am going to evaluate? X, y dx. Okay. So we will go and search for the equations. What is the equation of OA? Y equal to 0. So this is y equal to 0. What is the equation of your AB? X equal to 1. The next one is y equal to 2. So this is x equal to 1. This is y equal to 2. And the last one was, what was the last one? X equal to 0. So this is going to be the lines I am going to evaluate for. This is going to be the function I am going to evaluate it for. Y equal to 0. Substitute y equal to 0 over here. What will happen to the function? The function will entirely vanish and this integration will become 0. The next equation. What I have? X equal to 1. Put x equal to 1 over here. I have y dx. When x is equal to 1, what can you say about dx? Differentiate your x on both sides. 1 on differentiation gives you 0. So when I substitute x as 1, what will this dx get substituted as? 0. So what will happen to this integration? This will also become 0. Now come to the last one. X equal to 0. When I put x equal to 0, what will happen to this integration? This will also become 0. So only thing over here is y equal to 2. Substitute y equal to 2. What will be left out now? I will have integral over BC. Y has become 2. What you will have is x and the remaining quantity is dx. Okay. So I'll have to integrate along BC 2x dx. So along BC, I need the direction of my x. So let us go to my BC. Which is my BC? This is my BC. Now what are my coordinates of BC? X, comma, y. What is x and what is y? X is 1. What is y? Y is 2. What is the coordinate of C? X, comma, y. What is my x? X is 0. What is my y? Y is 2. Now see, where does your x vary? X varies from over here in this direction to over here. What is the value of x here? 1. What is the value of x here? 0. So x begins with 1 and x ends with 0. Keep in mind, you will have to go with the direction. Don't go in the opposite way. Okay. So where I will have to integrate? I will have to integrate it between x equal to, where is my starting point? X equal to 1 to x equal to 0. So let us now start the integration. 2 times x on integration is x square by 2. What is the limit to be applied? 0 to 1. So 2 and 2 cancels off. Apply upper limit 0. What is my lower limit? 1. So what is the total value? Minus 1. So what has happened to my integral over C? F vector dot dr vector now to be equal to minus 1. So this is my LHS. I am done with my LHS. Now go and check back what we had for RHS. RHS is also equal to minus 1. LHS is also equal to minus 1. So what we have done? We have verified the Stokes theorem. So that's all, children. The problem seemed to be very tough, but when you start evaluating, the things will fall in place and it will become very easy for you. Okay. Try to visualize things, try to understand the concept, then the problem is very, very simple. Thank you.